Hello there, mathematicians. Let's just hop right into example 1 on this part of the video. So we need to solve for x, and we have an x to the second power, which tells us it's a quadratic, so we should be thinking factoring and solving, or solving quadratics using different methods. So first thing that we learned with these, okay, the methods that we know so far are to set this equal to what? Well, set it equal to 0. So in order to do that, we'd have to get this 25 on the other side. So we would subtract 25, subtract 25. Again, we're kind of pretending like we don't know anything about this objective. If we just saw this problem, this is what we would do first. That leaves us with x squared minus 8x minus 9 is equal to 0. Okay. Now we should be thinking AC method. Okay. This tells us, again, you should know this stuff, and if I say anything and you didn't remember this, you need to hit pause and make a note in your own words with some arrows. Okay, this minus here on the constant tells us that we'll have two different signs. So what multiplies to be negative 9 and adds up to a sum of negative 8. Okay? Well, the answers to that, we would have negative 9 and positive 1. Okay, and that adds up to be the negative 8. So we can rewrite it, expand that middle term by doing x squared minus 9x plus 1x, those are the two factors, minus 9 is equal to 0. Now if you wrote it the other way, x squared plus 1x minus 9x minus 9, that would also be fine. Now we can solve it using grouping. Okay. And for each one of these, let's see this, I can just pull out an x, leaving me with x minus 9. This one, I can only pull out a 1, positive 1, leaving me with x minus 9 equals 0. Okay, hug your two GCFs, so x plus 1 and x minus 9. Again, we're solving because it has an equal to sign, so we need to set both of these equal to 0. So equal to 0, we would get, if we solve for this x, we would get negative 1 and positive 9. Okay. Again, always look to do things just the old way that we know. Okay. Now I'm going to teach you a different way, what we just learned about completing the square. Okay. So let me get a new slide here. Okay, we have the exact same problem, and you guys can just draw a vertical bar and put this same problem off to the side next to example 1. Alright, completing the square. This part of our quadratic, right here, we should be able to see this, and again, this kind of takes training our eye and knowing the patterns. We should see that this is a perfect square trinomial, okay? Because what the two factors for this would be x minus 4 and x minus 4. Again, a perfect square trinomial. And then now it still equals that 25. Okay. Now, how else can we write x minus 4 times x minus 4? Well, we can just rewrite it as that squared because it's being multiplied by itself. Okay, and that equals 25. Okay. Well, this goes back to yesterday. How do we solve this? Okay, well, we solve it using the, wrong button. Okay, to undo x minus 4 being squared, we take the square root. That will cancel. Okay, the square root of 25. Do not forget this. I've seen a lot of you do it. You need the plus or minus 5. And then we have the x minus 4. Okay, so then we take that to the other side. So it would be x is equal to a positive 4 plus or minus 5. Okay, so our answer is 4 plus 5 would be 9. 4 minus 5 would be negative 1. Okay. Now, if you want to rewrite them with the smaller number first, that's fine. Okay, what do you notice? You get the same answer, and you should. It's the exact same problem, right? You should get the same answer. Okay, but this, we solved it by completing the square. We saw that there was a perfect square trinomial, okay, and we got the two binomials that make that a perfect square, and then we just showed them as being squared. Then we went back to yesterday by solving it using these square roots. Okay, so another example. Okay, this one says to find the value of c that makes this expression, this trinomial, a perfect square trinomial. Make sure you underline that perfect square trinomial. Then write the expression as a square of a binomial. Okay. Well, we've already discovered in class, we discovered, okay, where we get the formula for finding what this value can be. And we learned that the formula was just b over 2 squared. That's what it would take to find, remember, that missing piece. Let me see if I can draw a quick picture of it here. It might be kind of hard on the iPad. Okay. To find that missing piece, the area of that was b over 2 squared. So well, no, that will, if we do that, that will complete the square. Okay. So we can do b is 16, so 16 over 2 squared, which would be 8 squared, which is 64. So what is the value of c that will make this a perfect square trinomial? C is equal to 64. Okay? Now on this one it also said to write the expression as the square of a binomial. So if we plug that into, so plus 16x plus 64 is equal to 64, because you have to add that to both sides. Okay, this is a perfect square trinomial. So this would be x plus 8, and then x plus 8 is equal to 64. And what did it say? It wanted the expression as the square of a binomial. So the binomial would be x plus 8 squared equals 64. Now it doesn't say to solve. Pretty much it's just kind of looking for this part right here. Okay, so that would be the answer to number 2. Let's go on and do the next one. Okay, on example 3. Again, forget about this lesson right now. We need to get better at just looking at problems and thinking, what all do we know about this? Okay, so let's look at this. We have an x to the second power, so we should be thinking it's a quadratic. We're solving because it has an equal to sign. So the first thing that we always look for is there GCF? Clearly not on this one, because a is 1 already. Okay, so the second thing that I'm kind of looking at is this a perfect square trinomial? So I'm thinking, what multiplies to give me 4 and adds up to be negative 12? Okay, and nothing will. So make a note, not a perfect square trinomial. Again, it's not a perfect square trinomial. That should be the first thing that we look at. Okay, and let's also make a note that we just tried this. The AC method doesn't work. AC method doesn't work. Okay, so that's when, okay, we can try to use the method of completing the square. And later we're also going to learn the quadratic formula. We could use that too. Okay, so completing the square, it needs to be in the format of x squared plus bx equals c. Okay, so we need to get this 4 to the other side. So to do that, x squared minus 12x is equal to negative 4. Okay, now to complete the square, we do b, which is negative 12 over 2, all squared. So that would be negative 6. And we talked in class about the sign doesn't matter on b, because when you square it, it's always going to be positive anyway. But I think it's just good habit to get into to always include the sign on it. That way, because with other things, quadratic formula stuff, the sign does really matter. Alright, so that would be 36. So I can rewrite this now. X squared minus 12x plus 36. And remember, so that we're not actually changing the value of the expression, we can't just make up and put 36 on the left side without putting it on the right side. Because again, whenever you do the exact same thing to both sides of an equation, it doesn't actually change the value of it. That's why we can do it. Okay? Now this right here, okay, what multiplies to give me 36 and adds up to be negative 12. The signs are both the same because this is a positive. And now that I look here, that tells me, oh, they're both a negative. So this one would be x minus 6. X minus 6 is equal to 32. Okay? Or I can rewrite that. X minus 6 squared is equal to 32. Okay, so now this goes back to what we did yesterday or in the previous objective. We take the square root of each side because the square root cancels something being squared. And I get x minus 6 is equal to plus or minus the square root of 32. Oops. Okay. Now I'm going to take this work up here. To get that x solved for, we need to move that negative 6 to the other side. So we get x is equal to a positive 6 plus or minus the square root of 32. Now I'm going to simplify this radical, and this is actually the next unit, but I'm going to simplify it. Those of you on math team, you should know this. Okay, what we need to look for is a perfect square, and the largest perfect square that goes into 32. So again, perfect squares are like 1 times 1 is 1, but that doesn't do us much good. 2 times 2 is 4. So 4 is a perfect square. Okay, what's the next perfect square? Well, what's 3 times 3? 3 times 2 is 9. So 9 is a perfect square. 4 times 4 is 16. 16 is a perfect square. Okay, so this one, the perfect square that goes into this, 6 plus or minus, we can simply break this down and rewrite it a different way. Again, not changing the value. Square root of 16 times the square root of 2. Okay. Well, we know, because if you multiply those back, you get right back to 32. We know that the square root of 16 is 4. Okay. Square root of 2 cannot be simplified. So this is your simplified answer all the way. X is equal to 6 plus or minus 4 root 2. Okay? Okay, this is the next example. So make sure you use cups and read this first. Hit pause, read it, and think about how you would start setting this up. In fact, using a pencil, try setting this up. You should have the background knowledge to do it. Okay, should be off pause now and have some work down. Okay, so if your work is, over here, you guys can draw a line and do, the notes right over here. Okay, and then change your work if you need to. All right, the area of a rectangle. Okay, first of all, right when I'm reading that, I'm thinking, well, how do you find the area of a rectangle? Area is equal to length times width. Again, looking at keywords and thinking, what do I know about that? Okay, the other thing, I would draw it out. Okay, draw out a rectangle, length, width, okay, just so you can visualize it. Is means equals 72. So now, when I'm thinking about this formula, I'm no longer writing A, I'm writing 72, because that is the area. The length is 3 units, so now I'm going to start showing my work down here. So 72, which is the area, the length is 3x. The width is x plus 2. I know I need to multiply those, because that's the formula. Show your work for completing the square to find the value of x. So basically, we are solving for x. That's all we're doing. Okay. Now, before we solve any equation, we have to simplify both sides first. So 72 is equal to, we need to distribute 3x squared. So right away now that it's x squared, I know it's a quadratic. It's a little bit tougher to solve for x now. Okay, and then plus 6x. Okay, all right. Now I could move this 72 over here, okay, and then do the AC method. Okay, but before, again, it's squared. The very first thing that I should do is what? Think about that. What's the first thing that you should always look to do when factoring or solving? Okay, you better be telling yourself at this point it's GCF. There is a GCF. We can divide every single one of these terms by 3. Okay, so if we pull out a 3 from each one of these, we get 24 is equal to x squared plus 2x. Okay, now again, you could move this 24 to the other side. Can use the AC method. What multiplies to give me 24 and adds up to be negative, or adds up to be positive 2. And you could solve this one that way. Okay, but this one says what? Work for completing the square. So we got to use this method. Okay, it's already in the format that we want, right? The x squared plus bx is equal to c. That's a format that we want. So now we can find out, well, what number would complete the square? To do that, we do b. b is 2. Half of b squared. Well, that's 1 squared, which is 1. Okay, so now I can rewrite this. It would be, I'm going to change colors quick here, 24 plus the 1, we got to add that 1 to both sides, x squared plus 2x plus 1. And that should be a perfect square trinomial. If you can't think of the two binomials that are the same that get you back to that trinomial, then you did something wrong, because it should be a perfect square trinomial at this point, and it is. 25 is equal to. Okay, hit pause, make sure you get the two binomials down. Okay, you should have the two binomials down. It's x plus 1, x plus 1. Okay, so that's 25 is equal to x plus 1 squared. Solve it. Go ahead and do that. Hit pause, solve it, get your solution inside the brackets. You get 5 x, plus or minus 5. We can't forget that. Do it now. And then x plus 1. So how do we get this 1 to the other side? We end up, and you guys should have more room on your paper than I do here on my iPad. Okay, you end up with negative 1 plus or minus 5 is equal to x. Well, negative 1 plus 5 will give me 4. Negative 1 minus 5 will give me negative 6. These are your two solutions to this using the completing the square method. Okay? Alright, let's go on. Okay, it says find the value of c to complete the square. So x squared minus 5x plus c. Well, how do we complete the square? We should know how to do that. Go ahead and get started. Do this, try it on your own. Hit pause. Okay, to complete the square, we do the b, so in this case negative 5 over 2 squared. Okay, well, negative 5 over 2 would be negative 2.5 squared. Negative 2.5 squared gives you 6.25. Okay, anybody maybe thinking, can it be a decimal? Well, there's one way to check it. Okay, so far we think c is equal to 6.25. Well, that should make it a perfect square. So x squared minus 5x plus 6.25. Okay. This right here tells us the two binomials, okay, and the signs are going to be the same, and they're both going to be negative. So it's going to be x minus 2.5 and x minus 2.5. Okay, and if you want to see if that's correct, what can you do? Well, check and see if when you multiply that, you get back to this original one. So you can use the box method. And if you do the box method for this, okay, you would in fact get right back to this one, so you know that you completed the square correctly. Okay. Last example. Alright, it is find the value of c to complete the square. It gives you 8x plus x squared plus c. Well, what do we have to do first? We've got to rearrange it. X squared plus 8x plus c. Okay. So, to find the value of c that will complete the square, right when you see those words complete the square, you should be thinking, oh, b over 2 squared. That's that missing piece that will complete the square. Okay, so that would be 8 over 2 squared, which is equal to 4 squared, which is equal to 16. So, c, and we should have circled in that last one that c equals 6.25, because in this one, c is equal to 16. Okay. So, that is a subjective. If you need to rewind it and watch another example after you do a few problems, make sure that you do that. This can be kind of confusing at first, but then once it just kind of clicks, it just kind of becomes automatic. So we will practice this more with your homework corrections in class.